Okay, let's go over this. This is going to be your indication if you're ready for our first assessment. And this is just going to be on 3 sections within our chapter 1. Okay, so the first thing we learned 4 different types of functions. So they should be very easy to identify either by the rule or by the graph. So I have a graph here. When you see a V, you have to know its absolute value. Okay, I'm not going to be asking about the domain and range, but later on you will need to make sure you understand the domain and range of every type of function that we do. Okay, and right now the domain is always going to be our reals. The range will depend. So here we have a clear low point. So the lowest y value is a 0. All the other y values are above it. So y values would be greater or equal to 0 if I asked about the range. Okay. For a line that's going up forever and down forever, the range is all reals, but this is definitely a linear situation. Okay. We know that U-shaped graphs are quadratics. It's to the second power. So the rule would have an exponent of 2, but we should know that it's quadratic. Okay. And then finally, the last one, a flat line is just a constant. It never varies. All the outcomes are the same. Okay, so that is a constant. Okay, so expect questions just like this on your assessment for chapter 1. Okay, this next part should be very easy to identify. We have a rule, and notice there's no absolute value bars, so it can't be absolute value. Notice that it's just an m. My variable is an m, so it does vary, so it's not a constant. And I don't see an exponent of 2, so it's not quadratic, which only leaves a linear situation. So what type of function is used in this model? It has to be a linear of our 4 choices. Okay? What is the value of m when the ride begins? So when you first, m represents, so anytime you're, given a word problem, make sure you read the situation. We're given this function based on f of m, where they tell us m represents the length of the trip in miles. So when you first get in this car, you went nowhere. You went 0 miles. So what is the value of m? Miles? Well, m is 0 when you first get in. Okay? What is the cost of a 10-mile trip? Well, that's what this function does. It tells you if you replace the m with a 10, so the function at 10 is a simple calculation. Okay? So I'm just going to pick up my trusty calculator. And all we have to do is calculate this simple 2 plus $1.75 times 10. And we're going to know that trip, that 10-mile trip, cost $19.50. Okay? Not hard. And then here, if our bill was $44, okay? So if the outcome, the f of m, that's your y, your outcome, we know the cost of the trip was $44. It's very easy to solve a 2-step equation for n. Okay, so all we have to do is subtract the 2, it becomes 42. And then I have to divide by $1.75. So m in this case would be 42 divided by $1.75. It's going to be a 24-mile trip. Okay, so again, linear situation, super easy, very easy to identify. Has to have a variable, and it has to have the power 1, not 2 to make it quadratic or a higher power. So hopefully that problem is very easy for you. Okay, this next section we have to identify the function. So here's your clues. Hey, I see a power of 2 has to be quadratic. So it is a quadratic function. And then we have to look at what we're doing with that x squared. So the first clue, we see a number in front that is less than 1. So we know that's going to be a vertical shrink, okay? Again, think of your height times 1/4, it would be a lot shorter. Next thing I look at, hey, are we doing anything with our input? So we are subtracting a 5. So when you subtract, you're actually going to shift it to the right that many units. So in this case, we're shifting to the right 5. And then hopefully the easy one, if you see a number on the outside, I see a -3. I know it is down 3. And like I said, we can confirm all that on a calculator. So if you simply go to your y equals screen, we type in this rule. So remember, fractions just put in parentheses, 1 divided by 4. I have x. Remember, your x is underneath the mode. So I have x minus 5, close the parentheses. I'm going to square it, and then I'm going to have a -3. And make sure it's -3 and a -3. Okay, so we should see this. It's going to be shifted to the right. It's going to be a little bit wider, and it's going to be down 3. So it's going to be in the 4th quadrant, the vertex. So I expect it to be down here. All right, there it is. Okay, I knew it was a shrink. I knew we shifted to the right, and I knew we shifted down. Okay, so again, if you're not sure, especially left and right, type the rule into your calculator. Okay, the next one, obviously, is absolute value. Okay, so if you see those straight bars are absolute value. And this time I see a negative in front, so we know it's a reflection. That V is opening down. Okay, so it is a reflection, and you must use the word reflection. You can't say flip. So make sure you use the proper term. It's a reflection. Then I look at the 2. The 2 is greater than 1, so it is a vertical stretch. Okay. Here, since it's a +1 inside with the x, we now know it's going to be to the left, left 1, and finally up 7. So by knowing that, we should know what the graph's going to look like, but I'm going to quickly show you. Okay, I'm going to go to my y equals screen once again. This time I must type in -2. Remember the math key. So I hit the math key, which you can't see. Right there's the math key. And push over, option 1. There's my absolute value bars. I'm going to type in x plus 1. I'm going to push away, and I'm going to put the +7. Okay, so we know it's going to be an upside down V. It's going to be a little bit skinnier because we stretched it out. We know it's going to be to the left 1 and up 7. So the vertex is going to be in the 2nd quadrant. So when I hit graph, I expect it over here. Right there it is. There's my upside down V. Okay, so again, being able to look at a function and understand what the numbers will do to the graph, very important throughout this year as we learn other types of functions. Okay, so once you had plenty of practice of doing that with the big idea assignments, so make sure that really makes sense. Go back and look at some of the examples in our notes. Okay, this next section, we're going to transform a linear situation. So it's 9x minus 12, the rule for our linear situation. And the first type of transformation, we want to do a vertical shrink with a factor of 2/3. So you have to remember, vertical stretch and shrink, where it's a multiplier of the entire rule. So I'm going to take this 2/3, less than 1, so it's a shrink, times 9x minus 12. Okay, I'll call this g of x. Okay, so then I just want you to clean it up. It's good to show this on your exam, but then I would want you, and if you have trouble multiplying with fractions, all you have to do is put 2/3, parentheses, 2 divided by 3, in parentheses, times 9. Okay, we know it's 6. I know 3 goes into 9. 2 times 3 is 6, so it's 6x. And then 3 goes into 12 4 times. I know it's going to be a -8. But again, you need a calculator. 2/3 times 12 is going to be an 8, so it's a -8. So that is a vertical shrink of this linear function. Okay. A reflection, you just have to remember, super easy, you did these in big ideas, you must make sure you distribute that negative. So when you distribute the negative, it's going to be -9x and a positive 12. That's how we reflect, and you can check on a calculator. You can see that it is truly a reflection, okay? This next part, now we're going to transform an absolute value function, okay? So we already know this v is already to the right 8, but we want to now, so for this first one, we're going to move it to the left. So I have x minus 8. There's your original function, already 8 units to the right, and I'm going to bring it back to, so since it's a horizontal movement, we go inside and put a plus 2. Okay, it's really minus and negative 2, but it's a plus 2, and then clean it up, and you'll have the absolute value of x minus 6. Now it's only 6 units to the right. So the original was 8. The new one is now 6 units because you brought it back 2 units to the left, okay? So now this one, super easy. It's down 10, so we don't change what's inside. So what's inside, we're not going to go back to the original, so make sure you go back to what we have up here. So the original v x minus 8, absolute value of x minus 8, and then to go down, I just need a minus 10 on the outside, and I can't do anything else with that, okay? You can't simplify that, okay? It's not going to become a negative 18, okay? X minus 8 must stay inside to show that it's a shift to the right, and then the minus 10 shows everything is shifted down, okay? Now, this problem, it is so easy, okay? Do not allow yourself to get this wrong, okay? And do not spend more than, this should take no more than 3 minutes, okay? So I am telling you the answer to the system. I am telling you x is 9, y is 0, z is negative 4, and I just want you to figure out a, b, and c. So all we have to do to find a, I take negative 2 times 9, my x value, plus 0, my y value, plus 4 times negative 4. Okay? Whatever that is, and again, you could use a calculator. So negative 2 times 9 plus 0 plus 4 times negative 4. Our calculator follows order of operations. It knows how to calculate that. Okay? So I know A is negative 34. Okay? The next one, when you do the B, it's the same concept. All we have to do is substitute in. So I'm going to write B equals 9 plus 3 times 0 minus, now just be careful of minus and negative. Okay, a lot of students struggle with that. I'm actually going to do this first in my head, and then I'll check it on the calculator. I know that's 9 plus 4, which is 13, but I'll show on a calculator. So test time, 9 plus 3 times 0 minus negative 4. So again, oops, make sure you can see that. Okay, so the rule is 9 plus 3 times 0 minus a negative 4. Calculator knows order of operations. It tells you 13. Okay, and then C, 4 times 9 plus 0 minus 6 times negative 4. That's going to be 36 plus 24. We'll use a calculator. You can see it there. So let me clear that. 4 times 9 plus 0. I guess I don't need to write plus 0, but I did. Minus 6 times negative 4. And you're going to end up with a value of 60 for C. That's all you're doing. Okay, nothing else to do to that problem. Just substitute x, y, and z and calculate each equation, okay, to find A, B, and C. Okay. Okay, our last page, we have some systems to actually solve now. So when you're looking at number 13, the way I'm going to solve this may be different than how you solved it. You just need to make sure we agree on the same answer, though. So no matter what technique you use, you should agree on the final solution. So I see, though, we already have an equation missing a z. Okay, it's always nice when that happens. So I'm just going to rewrite this equation. We have a 5x plus y equals 10. Okay, no z. So that's going to force me to look at these two equations here and get the z's to cancel out. So what I'm going to need to do, right now I have a 2z and a negative 6z. I'm going to triple everything in the middle. So I'm going to put a little 3 here, and then we're going to add them together. Okay, so again, be very careful with your handwriting. Okay, so 3x plus 3y plus 6z equals 12. Don't forget to triple that number. Okay, the bottom equation, I don't need to change. It's going to stay at 2x minus 3y minus 6z equals negative 5. And we're going to see not only will the z's cancel out, but will the y's. So this is actually a very easy question. Okay, so at this point, we're going to know what x is right away. Okay, it doesn't always happen this way, but take advantage of that. If you see this, this becomes a 5x. The y's cancel out, the z's cancel out, the numbers become a 5. I divide, and we get x is 1. Okay, which makes it very easy then to find y right away, because I'm going to plug that 1 in for x, and that's a super easy equation to solve. And just like that, I know that y is 5. Okay, now I have to go back to one of my equations with all 3 variables. I'm going to use the middle one. So the middle equation is x plus y plus 2z equals 4. I'm going to replace the x with a 1, my y with a 5, and then it's equals, or plus 2z equals 4. So this is 6 plus 2z equals 4. We'll subtract 6 on both sides. We'll get a negative 2. We'll divide, and we get z is negative 1. So you want to write it as an ordered triple. And we are finished. And again, if it's the test, take 2 seconds. I'm going to check this bottom equation. I should get negative 7 when I type 2 times my 1 minus 3 times 5 minus 6 times negative 1. That should come out to negative 7, and it does. So it tells me my answer satisfies all the equations. Okay, so I feel very good about that answer. The next one, okay, the clue is we're missing y's. Okay, so again, when we start out, expect some sort of like little hint to get you started on for the test. I doubt if I'll have a question where it's all 3 variables unless it's a bonus. Okay, so here, circle this. Realize we're missing the y's. Okay, so I'm just going to rewrite this equation. Let me draw a line here to separate the problems. 5x plus 4z equals negative 22. Okay, so I'm going to take the top 2 equations. I need my y's to cancel out. So to get opposites, I have a 2y and a y. I'm just going to multiply the middle equation by negative 2. So I'm going to carefully rewrite, so don't make a little typo. Be careful with your handwriting. Make sure z's don't look like 2's. So there's the top. When I multiply the middle, I'm going to end up with, what is that, 34. So be careful of your calculations. But now when I add, my y's are going to disappear. So I have negative 5x. The y's disappear. I'm left with minus z equals, that's going to be just 13. Okay, and again, you always have a calculator just to double check to make sure you're not making a silly calculation error. Okay, so there's my other equation. I'm going to line this up. And the good news is, I don't even have to work to get opposites. The x's are already opposite, so that's always convenient. So for this system here now with just x and z, I can just add right away. The x's are going. 3z equals, that's going to be a negative 9. And z is negative 3. I feel good because I won't give you any fractions or decimals. Okay, so now it's a matter of simply just backtracking. Okay, so now I can plug this z here and find what x is. So I'll write it here, 5x plus 4 times negative 3 equals negative 22. So 5x minus 12 equals negative 22. I'm going to add 12 to both sides. We're going to get 5x equals negative 10. X is negative 2. Okay, so we now know that x is negative 2. All we need to do is find y. And I'm going to plug into the middle. You can plug into the top if you want, but middle looks a little bit easier to solve for y because it's already just a y. So 4 times negative 2 plus y plus my z, which is negative 3, and that should equal negative 17. Okay, so this is negative 8. That's a negative 3, so we're going to have y minus 11. And all I need to do is add 11, and I get y is negative 6. So I'm going to write this as an ordered triple, negative 2, negative 6, negative 3. We'll box it, and we feel good about that. And again, if you look at the clock, hey, I have time, double check. Perhaps plug this into the top equation. 3 times negative 2 plus 2 times negative 6 plus negative 3, it will come out to negative 21. Okay, so then the last question, this is just a reminder, when you go to solve a system, if you get a false statement, here we have actual solutions. We have one solution here. We knew the answer is checked, but if you're solving a system and say all your variables cancel out and you're left with a false statement. So we're supposed to describe the difference between a system with no solutions. So a no solution, this results into a false statement. Okay, false statement, and I'm just going to show something like 0 equals 5. Okay, so anytime in mathematics you see a false statement, we know no solution. Okay, if we have a true statement in mathematics, so it's a true statement like, meant, like 0 equals 0 or 5 equals 5, then you have many or infinitely many solutions. So infinite solutions. That's the difference. Okay, those are those special cases. Those are the ones that can be done very quickly. So that is your test. Okay, or a quiz is your first assessment's not worth a lot of points, but it does go into your exam column. So you definitely want to demonstrate that you understand these problems. Go back, you can open up past big idea assignments, look at the problems, see how you answered them, see the correct answer, and be ready for this first assessment. We want everyone to start off to a good start with this first chapter. So thanks for watching. Good luck on your first assessment.